IoT functional blocks, IoT communication models, and IoT communication APIs. First, let us see what are the functional blocks. What does an IoT system do? It identifies, senses, actuates, communicates, and does management. An IoT system comprises of the number of functional blocks that provide the system the capabilities for identification, sensing, actuation, communication, and management. First IoT block is the device. It consists of the electronics part and the software part. Communication. An IoT device has to communicate with its environment. It has to give directions on what to do. So that is communication. Services. Of course, in our wheelchair example, there is only one service, movement of the wheelchair in a particular direction based on the human instruction through his hand. Management. What are the mistakes done? How far it is accurate? And many other statistics. Management may also include the cost and other aspects. Security is the main thing. If it is hacked or if it is attacked, then some problem may come because it is through internet. There is always a chance of hacking or attacking. So security must be there. And what is the application? In our case, in the wheelchair case, it is moving the wheelchair in a particular direction. Okay? Then coming to the communication models, there are four models: request, response, the client request, and the server response, sensor response. Publish, subscribe. Push, pull. It is through a queue. Some data is pushed into a queue and it's pulled by the server. Exclusive pair is the normal. You start the communication, then you do the communication, then you close the communication. Let us see each of these in diagrammatic form. In the request response communication model, there is a client and there is a server. The client sends a request to the server. The server receives the request from client, processes the request, looks up, fetches resources, prepares response, and sends response to client. The resources are fetched based on the requirement. Then the server prepares the response and sends a response to the client. That's where it stops. This is a request response communication model. You have publish, subscribe communication model. You have a publisher, you have a broker, then you have some consumers. First, publisher sends messages to topics. There will be topic 1, topic 2. Here are more topics. Say topic 1 and topic 2 are there. Each has subscribers. In the topic 1 it is consumer 1 and consumer 2. In topic 2 it is consumer 3. Okay? The publisher publishes a message to topic 1. The topic 1 processes it and sends it to the consumers 1 and 2. Similarly, publisher sends a message to topic 2. Topic 2 processes the message and sends to consumer 3. That is the publish subscribe communication model. Push-pull communication model. You have a publisher and you have a consumer. There will be more consumers. Here he is taking 2 consumers, consumer 1 and consumer 2. Sends message to Q. Then consumer 1 pulls its message from the queue. Similarly, consumer 2 pulls its message from Q2, and this way what is published is known to consumer 1 and consumer 2, what is relevant to them. Then they take action. Then activation takes place. Exclusive pair communication model. Request to server connection, request to set up connection. Initially, a connection is set up. Then the server sends a response accepting the request. Then the client sends to server a message. The server processes it and sends the message to client. Then the connection is closed. Initially, the client sends a connection close request and the server closes the connection and sends the response. IoT communication APIs. REST, you will see the next slide what REST stands for. Based communication APIs and WebSocket based communication APIs. These are 2 communication APIs. The first is REST based communication APIs and the second one is WebSocket based communication APIs. We'll see in detail about these 2 in the next few slides. REST stands for representational state transfer. REST stands for representational state transfer. REST is a set of architectural principles by which you can design web services and web APIs that focus on a system's resources and how system resource states are addressed and transferred. Basically, here you design web services and web APIs, and what does these web APIs and web services do? They focus on system's resources and how system resource states are addressed and transferred. REST APIs follow the request-response communication model. That the server, the client requests, the server processes, allocates the resources, and sends a response to client. The REST architectural constraints apply to the components, connectors, and data elements within a distributed hypermedia system. We'll see what are those constraints in the next few slides. Here we are mainly interested in the set of architectural principles by which you can design web services and web APIs. So there will be some constraints that apply to the components, connectors, and data elements within a distributed hypermedia system. Constraints. First constraint is client server. The client has separate concerns and server has separate concerns. You have to separate those concerns. Okay? Stateless. Each request from client to server must contain all the information necessary to understand the request. The session state is kept entirely on the client. So client is more responsible and it is stateless. Cache able. Cache constraints requires that the data within a response to a request be implicitly or explicitly labeled as cacheable or non-cacheable. The response should be labeled either as a cacheable or non-cacheable. Layered system. See, the components can see only their layer. They cannot see beyond the immediate layer with which they are interacting. So each layer, each component can see only its layer and not other layers. Uniform interface. Interface constraints requires that the method of communication between a client and a server must be uniform. Uniform interface. Interface constraints requires that the method of communication between a client and a server must be uniform. How are client and server interfaced? The communication between a client and server must be uniform. That is the main constraint there. Code on demand. Servers can provide executable code or scripts for clients to execute in their context. When client needs some code, the server sends it and the client can execute it in their context. You can see at this figure for a minute. I'll come back to it in a minute. I don't know if it is clear to you, but to me it is not that clear. First, between a server and a client, we have packets sent. Client sends packets to server and server sends packet to client. Okay? The server attaches the resources that the client needs to execute. It may, for example, give the code. Okay? So, REST aware HTTP client. Packet consists of two things, HTTP command and HTTP payload. HTTP command can be get, put, post, delete. REST payload can be JSON or XML. HTTP server authorization and REST full web service. The resources can be URL, representations, and response. With some difficulty, I am able to see it. I hope you are able to see it. Here you can see initially client sends a request, get, put, update or delete with payload JSON or XML. Then a response is sent from the server to the client. It can be through in JSON or XML. Then the request with payload. Then the server sends the response. That is the request response communication model used by REST. Next, we go to the next one. So far, we were discussing one of the communication APIs, that was REST. Now we go to the second one, that is WebSocket based communication APIs. WebSocket APIs allow bidirectional full duplex communication between clients and servers. See, in the case of REST, first a client has to send a request to the server and the server has to respond to it. But here in WebSocket APIs, it allows bidirectional and full duplex communication between clients and servers. It follows the exclusive pair communication model. WebSocket APIs reduce the network traffic and latency as there is no overhead for connection setup and termination request for each message. Here, there is no overhead for connection setup or termination request for each message. That way, it reduces the network traffic and latency. The last topic of the day is IoT Enabling Technologies. They are embedded systems, they are wireless sensor networks, communication protocols, cloud computing, big data analytics. Can read them for a while. I'll go into each of them in the next few slides. A wireless sensor network comprises of distributed devices with sensors which are used to monitor the environmental and physical conditions. A wireless sensor network comprises of distributed devices with sensors which are used to monitor the environmental and physical conditions. So the key word is distributed devices with sensors. So each device communicates with the other and the work is done. A wireless sensor network consists of a number of end nodes and routers and a coordinator. Coordinator collects the data from all the nodes. Of course, in our simple case, it uses this wireless sensor network. Our wheelchair uses this wireless sensor networks. It has a number of end nodes and routers and a coordinator. Examples where wireless sensor networks are used are weather monitoring system, soil moisture monitoring system at various locations, surveillance system. Okay? Embedded system. An embedded system is a system that has computer hardware and software embedded to perform specific tasks. An embedded system is a system that has computer hardware and software embedded to perform specific tasks. Embedded systems range from low-cost miniature devices such as digital watch, digital camera, vending machines, appliances like washing machine or a wheelchair. Of course, our wheelchair uses wireless technology, but it is also embedded with some sensors. Communication protocols. Communication protocols form the backbone of IoT systems and enable network connectivity and coupling to applications. Communication protocols form the backbone of IoT systems and enable network connectivity and coupling to applications. Communication protocols allow devices to exchange data over the network. C. Communication protocols enable network connectivity and coupling to applications, and they allow devices to exchange data. Those are the three purposes of communication protocols. Okay? You can look at for a minute. I'll come back to it. application layer. It's sorry, let us come from the application layer. We have HTTP, COAP, WebSockets, MQTT, XMPP, DDS. I think we came through this slide before because I asked you what is MQTT, and some of you have responded. Is he here today? What is MQTT? Respond. What is MQTT? What is MQTT? Please respond. Goran answer message, queue telemetry transport. You get a Notana message, queue telemetry transport. Okay. You can go through this. For example, in our wheelchair case, we are using Wi-Fi. You can use any of the other. The network layer IP4 version 4 or version 6 and 6 low PAL. Both of you get a dairy milk each. I don't know, Navya, you have to remember it. Both Manasa and Notana gets a dairy milk each for having responded. Is Mahesh not there today? See, last time we had a full subject on cloud computing, so I'm not going to discuss much. Basically, your data is stored in the cloud, somewhere in the server, maybe at 2 or 3 places, and it's fetched automatically when you require it. In this, I think pay as you use is the central theme of cloud computing. Pay as you use. There are 3 things. Pay as you go model. I would say pay as you use. Infrastructure as a service. Platform as a service. Software as a service. The last slide of the day, big data analytics. You see, today the data is huge and it is difficult to store, manage, process, analyze the data using traditional databases and data processing tools. That is why big data has come up. And today we are able to process and analyze huge volumes of data and such a variety of data also. Some examples of big data generated by IoT systems: weather monitoring stations, machine sensor data from industrial systems, health and fitness data, location and tracking systems.